Hi, this is Adam Lehman from Hamilton County Conservation District in Ohio. The following video is from part one of a four-part day-long workshop on estimating pollutant loads using the U.S. Environmental Protection Agency's Pollutant Load Estimation Tool, PLET. The workshop was designed to assist natural resource managers with estimating load reductions for conservation projects, as is often required by important funding sources. Video from other parts of the workshop can be accessed from the Hamilton County Conservation District's YouTube channel. A link to that playlist is provided in the description of this video. Part one of the workshop covered the context of why tracking pollutant loads and their reductions is important and the status of those efforts nationally and in the state of Ohio. Part two of the workshop covered an introduction and a detailed walkthrough US EPA's new pollutant load estimation tool, or PLET. Part three was an overview of the methods and parameters used by PLET and resources for estimating those parameters. And part four was a GIS and spreadsheet workflow demonstration for how to generate the needed parameters for an example agricultural treatment wetland project. Also linked in the description is a resources web page that was associated with the workshop. This web page contains lots of linked and downloadable resources discussed throughout the workshop. Thanks for your interest in the videos. I'm going to let Sid take it from here, and she's going to come at present the federal perspective on tracking load reductions across the nation.
Good morning, everybody. My name's Sid Curtis, and I work out of DC right now, but originally from the Midwest, working on 319 grants. And so we just want to give you a little context on how or why we think this is important. Thank you. This is context for us just knowing non-point source. I don't think we need to belabor this fact, but it is diverse and depending on land use and climate, there are a lot of factors to consider, and it is one of the most prevalent causes of water quality pollution in the nation right now. So next slide, please. All right. So there is a lot of work happening across the country. Currently, there's approximately 1,800 active on-the-ground projects going on across the U.S. And that accounts for over $250 million in 319 grant funds and 290 partner agencies. And if you look at the pie chart on the right, you see that this is the distribution we want to see. Like, local groups are the ones that make the work happen. They're the ones that deliver the water quality improvements. So like this conservation district, you all are the ones that are making this happen. Right. So just a real quick why and how these funds came to be. So Section 319 of the Clean Water Act, for those of you that are not familiar, it was established in 1987. It is a small, short read, but a lot packed in there. So a couple of pieces for us to keep in mind when we're thinking about why we need to report loading reductions. 319B establishes descriptions for a state to set up their non-point source management program. Once they have that program set up, they are eligible to apply for 319H grants. So 319H talks all about how those funds can be used. And a couple of important points that really lend themselves to the importance of reporting is that 319H8 requires that each year the state agency that's receiving the funds report on progress towards implementing their management plan. So if they're seeing non-point source challenges, they've laid out this strategy, they need to document that they're making progress in order to continue to receive 319 funds. And one place to help us make those determinations can be found in 319H11, which specifically calls out these annual reports including it specifically mentions where possible to include reductions in pollutant loading and improvements in water quality. So I wanted to show you all the statutory underpinning on why these pieces are so important to our program. So I just wanted to give you a snapshot. We've got the national load reductions. This just gives you an idea of what we're seeing nationally each year. Alex is the one that compiles the information and does all the QA. And all this is input through a database that Alex is going to show you a little bit, like as we start getting into the PLET model later. And just as a side note, all those stats on active projects and dollars and partners also come from those reports that include load reduction. So the idea is we use the pollutant load reductions to show these interim measures of success and that progress, but the idea is ultimately to improve water quality. And so that is another measure. So just these load reductions help keep us going, keep us engaged, let us report to anybody that's be it Congress or a local community member. Here's how the progress is going. And then from there, ultimately we see water quality improvements, and just wanted to show you that right now we're looking at over 10,500 miles of stream. And this is just since we started tracking it this way in 2005, and 250,000 acres of lakes, reservoirs, and ponds. So this, these loading reductions are a good interim step leading to the ultimate, goal of improved water quality.
We're going to pause now and we're going to hear Chris Neach, research ecologist from EPA's Office of Research and Development. And he's going to highlight a case study of trying to use that GRITS data to assess the impact of the 319 program in Ohio.
All right, so just a little bit of a backstory here about this workshop and getting the Office of Water, our Office of Water colleagues involved. I sit in the Office of Research and Development. I often say I'm a researcher, not a regulator, but my job is to help do science that supports our Office of Water colleagues, such as Sid and Alex that you're hearing from today. As part of that, I also work a lot with local watershed groups. Two that I'm most familiar with are the East Fork Watershed Cooperative, that is mostly Claremont County and Brown and Highland counties, and then the Regional Watershed Network that Adam and the Hamilton County facilitates, including Boone, Butler, and others from the tri-state region. So over the course of us looking into trying to understand how to measure the effectiveness of best management practices at larger scales, we wanted to dive into the grants reporting tracking system, or the GRITS, to see what information was in there and could we use that information to actually better link the projects that are going on the ground to water quality improvements in watersheds, and just kind of go about how that process might work. And I presented some of this content earlier at our watershed level meetings and as updates and overviews. And I think that kind of spurred Adam to consider this holding such a nutrient load or a pollutant load reduction workshop as we're having today. And when I heard he was interested in that, I had just been given a review of the PLET tool. This was back in the spring, and PLET had not actually been released. So as soon as I heard the interest from Adam, I contacted Sid and Alex, and we all started kind of sitting down, and that's how this all came together. So, but Adam by far and Hamilton County Conservation District has done much of the legwork on this. So really, really hats off to him. Thanks for making this possible. So yeah, we started studying this GRIT's BMP effectiveness at watershed scale problem a couple years ago. The relevance, as you just heard from Sid, is that the US EPA is spending millions as part of the 319 program to help address non-point source pollution. And as part of that, it maintains and requires states to use the grant reporting tracking tool, the GRITs, I'm just going to call it GRITs from now on, as a means of tracking program activities and program effectiveness. And our research objective here was using the information in the GRITs, can we conduct a statewide survey? We started out with Ohio because that's what we're most familiar with. Survey the 319 projects and try to link effort to water quality improvements. And our original intent was to indeed do a statewide analysis. And as we started diving into the information and where projects were located, we ended up refining our attention to the Cuyahoga watershed, and I'll explain why that is soon. So the overall approach of this effort was to work with the GRIT's database manager to help interpret information and extract the most appropriate data. We also spent a lot of time, as you'll see, working with the state level non-point source program managers, Rick Wilson, Martha Spurbeck, and John Matthews in particular. We conducted a cursory geospatial analysis to assess areas best suited for further study. We required high density of 319 effort and good water quality data downstream of that effort. And that really turned out to be really only one place in Ohio that we thought we could try to pull this off. And that was in the Cuyahoga watershed, as the only watershed meeting the criteria. And then we analyzed the GRITs, and we paired with Heidelberg water quality data for the Cuyahoga station in Independence, Ohio, to determine if implementation of BMPs through the 319 program is associated with decreasing trends in water quality. So because the Cuyahoga is an urban system, we focused on sediments. Our original intent was this was funded through a nutrient mitigation research effort in ORD, but we focused heavily on sediments. In this case, reasoning that most of the BMPs in the urban system of the Cuyahoga would be more likely implemented for erosion control. We were interested in determining if there was a decreasing trend in sediment loading in the river over the period of BMP implementation, defined by projects that we obtained from the GRITs. And if so, to what degree may it be associated with 319 funded effort? We used the WRTDS component of the USGS's EGRIT package. WRTDS stands for Weighted Regression on Time, Discharge, and Season. It's a way of doing time series analysis and normalizing highly variable discharges and concentrations to get loading trends. And this is all available in the USGS egrit.r package. So we queried the GRITs with the Oracle Business Intelligence, or OBI, reporting tool. We included completed projects specifying HUC 12s and BMP types, and we excluded outreach and education from those BMP types. And we also specifically excluded certain types of remediation actions like acid mine drainage. We focused on structural BMPs such as natural channel restoration, porous pavement, wetland restoration, conservation easements, etc. The completed projects spanned from July 2005 to December 2018, and we defined the study period as 2000 to 2018 to coincide with the mostly continuous time series analysis, a time series data from the river station monitoring station. Okay, so statewide at a Huck 12 scale, so all these black boundary lines on this state map are the Huck 12s in the state of Ohio. The ones in green all have had 319 funding between 2005 to 2020. And there were 101 Ohio Huck 12s with 557 BMP types from 161 completed 319 projects that we found. And recall that originally we were hoping to do what we could maybe call a statewide analysis, but trying to pair this information with water quality monitoring data really suggested that we were going to have to focus our effort up here in the northeastern part of the state. This is all the Cuyahoga River watershed, not all of it, but you can see that is outlined in red here. So that's where we started shifting our attention. This is a look at the BMP 319 effort implemented in the Cuyahoga. They call it the Crooked River that runs along this flow path here. And again, the Huck 12s in green here were had BMPs implemented through 319 effort. 75 BMPs over 21 completed 319 projects in half of the Huck 12s in the Cuyahoga. And again, we were using data from this long-term monitoring station that had data from 1981 to 2020, but a tree had fallen on that station in 2018. So we really ended up focusing our analysis on the 2000 to 2017 period. If you look at the trends in that water quality data, generally for the Cuyahoga, we're seeing that there is river discharge is slightly increasing over this 2-decade period. And interestingly, the total suspended solids or TSS concentration in the river is significantly decreasing. So this was an interesting find right off the bat. When you're seeing increases in discharge, you would expect, more potential for erosion, more potential for sediment resuspension, and perhaps then more total suspended solids concentration in the river. But in fact, despite that increasing discharge, we're seeing decreasing concentration in the river. That was a good find right off. So diving more deeply into the grants reporting tracking system for BMP effort in 319, this is a snapshot, BMP effort funded by 319 program. This is a snapshot of the BMP types that we found, everywhere from fish passage and dam removal, riparian buffers, to 1-2 ditch, a lot of stormwater improvement type BMPs, but wetland enhancement, wetland restoration. This table lists the number of those implementations of that type and the years that those were implemented. And you can see really popular ones that are getting funded through 319 are natural channel restoration and tree and shrub establishment, which have been receiving funding from 319 from 2008 forward, pretty much. Over $7 million has been spent on the 21 projects with a maximum grant funded for approximately $1.5 million for the Little Cuyahoga River Restoration Project in 2013. 19 of the 21 projects implemented multiple BMP types. This is what the load reduction estimates from those projects look like. This is what we will be workshopping on today, how to do these load reduction estimates. We identified 3 phases over this period of study. one in which there were no BMPs implemented, a second one from 2005 to 2011, where six 319 projects were funded for a total estimated load of about 2,600 metric tons at a cost of $1.9 million. And then a third phase from 2012 to 2017, where 13 were implemented at a load estimate of 1,600 metric tons for $4.7 million. And these disproportional amounts of load reduction for cost highlights some matters that you can't think of these projects in terms of directly proportional entities where the cost is synonymous with the load reduction potential. So of the 21 projects, only 19 of them had actual sediment load reduction estimates. So 3 projects we didn't have estimated loads for. We considered load reduction estimates for the dam removals, of which there were 4 one-time removals. Otherwise, we assumed that once the project was completed, that level of load reduction was happening going forward. And then based on this assumption about the load reduction estimates, by the end of the analysis period in which we assessed river trends, there was 2,647 metric tons per year of sediment abatement occurring from 319 efforts. So in 2017, there was 2,647 metric tons of abatement occurring from projects that had occurred between 2005 and 2017. So over the period, the cumulative sediment abatement was assumed to be 19,651 metric tons. So if you accumulate over that 2000 to 2017, 19,651 metric tons of sediment had been removed by 319 effort based on estimates from the grids. So when we pair this information with the trend in sediment loading in the river, which is in this graph, so the dark blue dots, so we've got time on the x-axis and loading of sediment. So this is the amount of load of the mass of sediment that's moving as total suspended solids through the river per year. And the dark blue dots are the actual annual loadings, and the light blue dots are the flow normalized loads, which we use to run the trend analysis, which we obtained from the WRTDS modeling. So you can see with these dots, this is the phases of the BMP effort that we just presented in the previous slide, where we had 0 occurring, and then with no significant change or even a slightly increasing change in the river. And phase 2, we had 6 319 projects going on. And in this phase, we saw a significantly decreasing trend in the load in the river. And then in the third phase, we had more 319 effort going on, but less sediment estimated reduction happening. And the trend coincided, or that 319 effort coincided with a plateauing trend. If we estimate a line of no change over this period, that's the orange here, and we take the difference between the orange and the end of the period, we essentially can account for about 2.2% of the mass of the suspended sediment that is no longer carried by the river. We could tag that to the 319 effort based on the estimates in the grids. So just saying that another way, the decreasing river trend produced about 885,000 megatons of deficit in the river over that period relative to a no change. We knew that the 319 effort produced almost 20,000 megatons of abatement, and that you take that over the 885 and you get 2.2%. So that sounds rather small for $7 million worth of effort. So caveats and conclusions here. We know that other abatement effort is taking place in the watershed, actually quite a bit. But despite a lot of effort putting into trying to figure out if we could document all that, we don't know where it is going on, and we definitely don't know how much extra effort is occurring so that we could compare those with the GRITS information. The 319 effort focused on the main stem. That was happening early on between the 2007 and 2011 phase. It was mostly main stem oriented, and that was the most significant change in the river. The 319 effort in phase 3 was more focused on hill slopes and in smaller tributaries, kind of stormwater management oriented, and it coincided with a plateau in the trend in the river. Overall, the evidence we have of an effect of a 319 effort in the river is rather circumstantial, but we can make quantifiable comparisons given the estimates in the grids. And the more uniformity there is in these estimates across projects, the more confidence we can have in using them. And that's really the intent of this workshop today. We think with finer spatial resolution, we potentially could find scale matches, spatial scale matches with more power to assess these linkages. But I want everybody to realize there are policy constraints to the EPA reporting in a level of finer detail than HUC 12. The state, I also want to note that the state uses 319 funds to monitor for improvements in aquatic life. This information would also be useful to assessing 319 program effectiveness, but it is not currently tracked in the grids. And I'll end it there. I think I got pretty close to where you wanted me to be at.
Right, that was perfect, Chris. Thank you. We've got a couple minutes for a couple questions, if anyone has them. I guess maybe the reaction button on the bottom of the screen, folks can just raise their hand and we'll select if anyone has any questions or comments. Oh, Michelle, sorry.
No problem. Morning, everybody. Great talk there. I'm just wondering about all the possibly millions of additional dollars coming from the NRCS side, state funds, and corporate projects. I'm so sad to hear that you couldn't figure out where or what was being spent. Can you tell me about those efforts to gain that attention? Were you thwarted? Yeah. Did you ask and they said no?
No, I'd have to dive into the manuscript. So by the way, this is all excerpt. This talk was excerpted from a manuscript that's under review right now. And we list all those agencies that we reached out to. Thanks to the state, they put us, Rick Wilson's crew put us in contact with many of those folks. And they were willing, they were certainly willing to help us out, but very few of them had documented site locations. And it became fairly clear that even though they could talk, they would start rolling off the top of their head where these projects were going on, trying to gather all that documentation and get it in a form and then run it through. And there was no exercises there was no systematic effort to try to estimate the load reductions coming from that effort. So we would have had to do all that on our own. And we just didn't have the capacity to do that. And essentially with our project team decided that trying to do this in even a semi-quantitative manner so that we could scientifically rationalize pairing that information with the information that we were getting from the grids was not gonna cut muster on the scientific side. So we kind of abandoned that process. And I do wanna, this is essential for us to be able to understand the impact that all of our mitigation efforts across multiple agencies and multiple levels of government are happening, but or the effect that they're having. But I can't overemphasize it seems like it would be an easy task, but it is a really complicated task. You're talking about many organizations that are going to have to start talking to each other more than they are now and tracking the same type of information. And so I just don't see this kind of thing happening. The fact that the 319 program has been able to do it is pretty amazing. You know, they pended funding on it, basically.
Well, I'm very interested in lending American Farmland Trust's help on the matter. And we have a farm bill coming up, and we don't have to wait for the farm bill, or we could be doing it outside the farm bill. But I would love to continue talking with you and you know, itemize all the problems, brainstorm all the solutions, and gather all the people. So I look forward to many more conversations. Thank you.
Fantastic. Sounds like we just made a pretty good connection there. I wish we had time for more questions on this topic. It certainly deserves it, but we got a lot to cram in today. So we're going to move on to the state of Ohio's perspective on tracking loads. Recall that, you know, this workshop has been marketed and is kind of focused on, you know, water resource managers that are coordinating these BMP projects and need to report their loads and their funding proposals. And so we've got representatives from two local funding programs that require these estimations. We're going to start with Rick Wilson with EPA because we've just been hearing about the 319 program quite a bit. So we'll hear from Rick for a few minutes, and then we're going to hear from Eric Sass with the Ohio Department of Natural Resources H2 Ohio program.
Welcome, everybody, and thanks for inviting me. I'm Rick Wilson. I've been with the 319 program here at Ohio EPA since I think like 2009. And then before that, I did permit writing and also spent a number of years inspecting and writing permits and investigating manure-related issues on farms, and got to see during that time how runoff happens and what type of controls are in place and the effectiveness of those controls. So I wanted to, I got just a few minutes, but I just want to give you some things that occurred to me as I was preparing for this on what the load reduction estimates, and we really have to focus on estimates because these are estimates that are based on research that has happened around the world and sometimes in our region and sometimes not in our region, oftentimes at plot scale and not necessarily real world, field by field scale, even though we are getting a lot more edge of field monitoring implemented and getting installed by USDA, ARS, and others. And we are trying to refine some of our practice implementation effectiveness numbers. But just to give an idea, Ohio EPA requires applicants to estimate the load reduction from their projects. And this is exactly what we've been talking about as far as nitrogen in pounds per year, phosphorus in pounds a year, and sediment in tons per year. Other projects like acid drainage or other projects we may have some other load reduction estimates, but we're now also including stormwater runoff volume, captured or treated, which we think is a big deal. We weren't covering that before, but we know that by incrementally reducing the peak hydrographs from whatever size watershed, we are probably going to reduce the loading or extra loading that compounds the problem through stream erosion or other scouring. So we think that's a big deal. But nonetheless, when we ask for applications, somebody has a project, let's say it's for a stream bank restoration or a floodplain expansion or both. We ask them to do a load reduction estimate. And a lot of times historically they've used Step L or they've called me directly, and we kind of get into, well, what is the, what can we reasonably expect through your project? So when we get applications in, this is a part of the application, and I wanted to just mention, I look at those numbers that come in. Is the numbers that they're providing, does it even measure up to reality? Are the loads that are being estimated to be reduced, do they exceed what the load is in the first place coming from that source and things like that? When we evaluate, and to do that, I look at tributary loading data and average loads coming from various regions around the state on a per acre yield basis, like phosphorus per pounds per acre of ag, phosphorus pounds per acre from urban and things like that. Things that we kind of have a good handle on. We don't think any BMP is going to reduce the load by more than 100%. And in fact, based on some of the slides I'm going to share here in a little bit, probably oftentimes we might overestimate what our expected load reductions are. It's also important to understand, and Chris mentioned this in his last slide, Ohio EPA monitors the effectiveness of practices based on Ohio water quality standards. And often cases, our standards are related to do we have the right kind and number of fish in our streams, warm water habitat, cold water habitat streams? Do we have the right insects? Do we have the appropriate and enough quality habitat in these streams? So we're measuring not necessarily load. We're doing indices around the state to see whether our fish and bug and habitats are improving. And load is secondary in a lot of those cases, because where we do have nutrient load issues locally in streams, in almost every case, it's a point source issue versus a non-point source issue, because non-point source pollutants pass through the system during high runoff periods and go to downstream uses like lakes or reservoirs. But nonetheless, we report load reduction. Just a quick idea of why I think this matters. And this is what we call a flow. And this is an example. This is pulled out of Hog Creek, Western Ohio, Lake Erie Basin. But when we see a river flow and what we have for load in kilograms per day, in this case, this graph on the bottom, 0 to 100, that represents the whole year. So if you see here, maybe 5% of the year, the flows in Hog Creek might be well above 300 CFS and are carrying 100 to 500 or so kilograms per day of phosphorus just in those runoff events. And then you have other wet weather events that are up to 20% of the time, or 65 days a year, are carrying more than 10 kilograms per day of phosphorus. But most of the time we're down here in the below 5 range, or below 5 pounds per day or kilograms per day of phosphorus. And we would expect, for instance, ag BMPs or urban BMPs to be really effective in this range, and maybe even 75, 80%. And I know I'm using vague terms here, but we see these load reduction estimates in percentages by BMP oftentimes. So when reality kicks in, you're like, would that builder strip handle the high flow event, or would almost all that load be reduced at 0% reduction? I think about these things when I look at load reduction estimates and what the real, are there factors of effectiveness that we can put onto those? And oftentimes I do when I'm looking at other people's submittals and where they seem to be a little high. And I like to err on reality versus big numbers, I guess. Here's another example from Paint Creek, again, showing load duration curve. 10% of the time we're getting 400 kilograms per day in this watershed versus 50% of the time we're below 30. And again, this mid to mid-high range for BMPs is where it's at, but we have to recognize that when you're getting into these highest flows, oftentimes most ag BMPs or urban BMPs are completely compromised. So what is the real load reduction? So maybe I'm adding more to this discussion than is needed, but it's the things we think about. I will say, I want to go back to this here. When we get applications and we don't evaluate or give more points high or low, depending on just how many pounds you're putting in there. Oftentimes an urban project might only get us 2 pounds of phosphorus and 14 pounds of nitrogen and 2 tons of sediment, but it'll get us 15 million gallons of stormwater reduced. And it's getting us to the point where we need to incrementally reduce these things. And moreover, in a lot of these cases, our real hope is that we get soil and waters who are willing to try new things or new water retention practices or an improved filtration practices or additional treatment through wetlands. We want them to become more comfortable with the install of those and be able to describe that those efforts are being implemented in a way that it doesn't affect an urban development project, or B, in a lot of cases, what we're really working on here in a lot of areas for far field reductions is nutrient load to like Western Basin, Lake Erie, or to the Gulf of Mexico. So we don't give extra points on just how high or low these things, but we do evaluate them on are these numbers we're getting in our applications actually, do they pass the straight face test? And if not, we'll work with those applicants to adjust those and making sure that they agree with our understanding of those. So I'll end there. I am excited. I have not gone through the new pollution load estimating tool yet. I had it open several times and then got waylaid. I'm excited to learn more, and you know, we want to continue to be a resource for all the applicants here. Keeping in mind in Ohio, a lot of our monitoring is not necessarily load reduction monitoring, or but we are looking at our fish and bug scores, which is how we rank our water quality. Thank you. With any questions, I'll be happy to answer now or later. And I appreciate seeing all these faces I know on the screen here today. Have a great day.
Thanks, Rick. That was super helpful perspective. We're going to pass the baton to Eric real quick, and hopefully we'll have time for a couple of questions after Eric presents from the H2 Ohio perspective from Ohio DNR.
Really good to be with you all today. Again, like Rick said, a lot of familiar faces here. I want to provide some context to the conversation from the state's perspective, from the ODNR and an H2 Ohio angle. I hope what I give you is kind of food for thought. I don't really have answers for anybody here, but I want to help maybe provide some context for how a state grant funding entity views some of these questions and tries to answer some of these questions. But a lot of what Rick and Chris were talking about is echoed here, where you know, we want to look at every potential nutrient reduction project that we might fund in an apples to apples way. And so the way we've done that so far at ODNR's H2 Ohio program is to do it ourselves. And that's not very sustainable when we look at the multitudes of projects that we fund. So we are looking to, and I think this conversation is perfect for this need. We're looking for a comprehensive, comparable approach that could be used uniformly for projects that come to us for consideration. Just real quick, where we're coming from here, you know, ODNR's H2 Ohio program is part of the larger H2 Ohio effort, which has its own unique tracking considerations when it comes to nutrient reduction. The Ohio Department of Agriculture working on best management practices, keeping nutrients on the landscape. Also wanting to track those targets, you know, against, or I guess wanting to track what they're accomplishing versus targets, and you know, and we're working on wetlands with a water quality focus. So this is so I'm the program manager for ODNR's H2 Ohio program. I work with Rachel Denauer and 2 summer interns currently. And we take a natural infrastructure approach. I mean, I think this is very similar to what Rick and his shop is working on through their non-point source 319 program. You know, we look at wetlands and floodplain reconnection, dike to coastal wetland connection, forested riparian buffers. We consider all those things kind of within that umbrella of natural infrastructure. And the body of research indicates that these are positive, cost-effective measures we can take when it comes to reducing nutrient loading, particularly, you know, in the context of watersheds where a lot of the pre-existing ecosystem function has been removed. We can think about the Maumee River watershed, the Great Black Swamp as a prime example of missing ecosystem services and putting those back in place. Yeah, there's indication from the literature this is cost effective. When we reestablish ecosystem services, this is a long-term benefit. And then, of course, there are plenty of corollary benefits to wetland restoration and similar natural infrastructure. And we don't really quantify those currently through our program, but we know that those co-benefits exist. We live at that intersection of nutrient management and habitat restoration, much like a lot of the 319 work that's being done. And so you can think about our approach as kind of, if you're familiar with, I think it comes from software development, this idea of agile project management. We take the bulk of the evidence and we choose an approach and we lean heavily into that approach. And then we track and monitor our progress on that approach and feed that back into adjustments in our program delivery. So we've gone big on wetland restoration across Ohio. You can see that we're largely focused in Northwest Ohio and the Maumee and Western Lake Erie Basin drainages, but we've also run 2 rounds of competitive grant funding in the Ohio River watershed. We look to do more of that, and we may do more of that on a statewide basis, kind of striking a balance between a discretionary grant funding model and a competitive model. And as we continue to roll out that competitive model and tweak that framework, I can see us asking for pollutant reduction estimates from applicants in a way that is consistent and comparable. And I think that's what is so exciting to me about the conversation today, making STEPL similar approaches more user-friendly and lowering that bar for potential applicants to our program. So just to simplify by the numbers of where we're at right now in terms of funding, we have over $100 million invested in this approach just since 2019. We're not looking to let off the gas. Over 100 projects that we've launched in 43 of the Ohio's 88 counties. 20 finished so far, and we take a very collaborative approach with our grant awardees. We consider our grant awardees project collaborators, and we share a common goal of nutrient reduction on the landscape. We're north of 10,000 acres right now. Over 100,000 acres of watershed filtered. So I have this sign in my office. This is our kind of catchphrase for H2 Ohio. It's probably backwards on your screen, maybe. The filtering process of wetlands improves water quality. And I like, whenever I see that, I think that could be an essay prompt. It's kind of our shorthand, but there's a lot of asterisk to that. As this group well knows. So as we lay out our program, we are engaging with the top minds in the space to help us improve the inputs into the estimates that we make and this community makes when it comes to what is a percent efficiency that we could assume for a particular type of wetland in a particular situation on the landscape. What are the easiest things that we can take into account when making these nutrient projections and trying to prioritize projects for their cost effectiveness. So we're proud to be engaged with the academic community actively in this process, and we want to tweak our approach as we roll down the road. So I'll leave it at that. Hope to be part of the conversation for most of the day today. And thank you all for having us here.
This has been part 1 of a 4-part day-long workshop on estimating pollutant loads using the U.S. Environmental Protection Agency's pollutant load estimation tool. Videos from other parts of the workshop can be accessed from the Hamilton County Conservation District's YouTube channel. A link to the playlist is provided in the description of this video. Thanks for watching.